All right, let's dive into one of the biggest questions you can possibly ask. Why is the universe the way it is? I mean, is our reality just some cosmic accident, one of countless random possibilities? Or is it the only way things could have ever turned out, all based on some deeper, hidden logic?
I mean, really think about it for a second. All the rules that run the show, from gravity holding us down to the weirdness of quantum mechanics, where did they come from? Are they just random settings on some cosmic dashboard? Or do they emerge from a principle so fundamental that they literally couldn't be any other way?
Well, in this explainer, we're going to look at two powerful frameworks that try to tackle that exact question. One comes from the world of pure mathematics, and the other, well, it comes from deep philosophy. And here's the crazy part. When you put these two ideas next to each other, they start to look like two different translations of the exact same story. So on one side, you've got the mathematicians with something called the Coherence Field, which pictures the universe as this dynamic, flowing landscape. And on the other side, you have the philosophers with the Theory of Objectivity, which tries to build reality from a set of unbreakable logical rules.
Okay, so first up, let's get our heads around this first world, the Coherence Field. To do that, I want you to imagine that all of reality, every single possibility, is one enormous, invisible landscape.
Now, the key concept here is coherence. And the easiest way to think about it is like the elevation on a map. You know, high up on a mountain peak, things are unstable, high energy. That's like high coherence, total chaos. But down in a deep valley where water pools up, it's low energy, super stable. That's low coherence. That's order. And basically, everything in the universe is constantly trying to flow downhill to find the most stable spot.
So what this means is that all the stable things we see around us, the stuff we actually call reality, they're not just random flukes. Nope. They are simply the structures that have managed to find the deepest, most stable valleys in this whole cosmic landscape. They've settled in. Now let's totally switch gears. We're moving from the universe as a physical landscape to the universe as a piece of pure logic. This is the theory of objectivity. And it doesn't start with physical dynamics at all. It starts with a simple, logical blueprint for what it even means to exist.
This whole theory kicks off with a really wild reimagining of nothingness. We usually think of nothingness as, well, just an empty void. But here, it's not that at all. Instead, it's a foundation of pure logical potential. It's like the basic operating system for existence itself, the set of rules that any reality would have to follow.
And out of this nothingness, you get a few core rules, or axioms. These are the non-negotiable terms and conditions for existing. For instance, to be a distinct thing, you gotta have an edge, right? Something that separates you from everything else. To exist, you can't be alone. Your existence has to be relational, observed by another. And complex things? They have to be built out of simpler parts. Makes sense, right?
Okay, let's pause for a second. We've got this mathematical landscape where everything is flowing downhill. And then we have this philosophical blueprint built on strict logical rules. On the surface, these sound like they're from two completely different planets. One's written in equations, the other in prose. But what if they're not?
Because this is where things get really interesting. When you stop treating them like they're competing with each other, and you start trying to map the concepts from one onto the other, like you're translating between two languages, something absolutely incredible starts to happen.
And wow, look at this. It's almost a one-to-one match. That philosophical rule about needing a boundary, bam! The mathematicians have a name for that, a curvature shift, which is basically just the edge of one of those stable valleys. The idea that things are built from smaller parts? Well, the math calls that nested basins of stability. You can think of it like smaller puddles forming inside a larger lake. Even that super abstract philosophical idea of two observers finds a direct, concrete parallel in the math. It's like they're describing the exact same architecture, just using different words. I mean, this connection is just brilliant. The philosopher is over here saying, logically, for something to be distinct, it must have an edge. And the mathematician is over there pointing to the landscape and saying, yep, got that right here. It's the rim of a valley. See where the curvature changes sharply? It's the same thing.
And it's the exact same story for that two observers idea. Philosophy says, hey, existence is relational. It can't happen in isolation. And the math shows us that for something to be perfectly stable in a valley, it needs two conditions. The bottom has to be flat and the walls have to curve up. So two logical observers become two mathematical constraints. It's a perfect match.
So, what does this all mean? Are these just a bunch of clever coincidences, or are we genuinely looking at two different descriptions of the exact same underlying reality?
The proposed synthesis here is, well, it's breathtaking. The idea is that these aren't competing theories at all. They are two sides of the same coin, complementary views of a single generative architecture for existence. One gives us the logical why, and the other gives us the mathematical how.
There's this one line from the source material that just captures this idea so beautifully. It says that the mathematical landscape of coherence is the physical shadow that's cast by the deep logical rules of existence. I love that analogy. The logic is the real object, and the physics we experience is its tangible shadow.
In other words, the theory of objectivity gives us that fundamental, logical scaffolding. It's the blueprint that explains why reality must have certain properties. And then the coherence field comes along and provides the dynamic, mathematical machinery that brings that blueprint to life, creating the universe we can actually see and touch.
So here it is, the ultimate takeaway. The laws of physics might not be arbitrary at all. They could be the direct, inevitable consequence of a few simple, logical rules for what it even means to exist. The universe follows these mathematical laws because, at its very core, it's built on a foundation of pure, unshakable logic.
And that leaves us with a final, provocative thought to chew on. We've just seen how two vastly different fields, mathematics and philosophy, can converge to tell one single, coherent story about the nature of existence. And it really makes you wonder, doesn't it? What other languages of reality are out there, just waiting for us to learn how to translate them, that could reveal even deeper truths about our universe?